Hello. Today I will provide additional evidence for the alternative postulates for special relativity proposed in one of my previous videos. In short, I postulate that the speed of light does not depend only on the speed of source and that absolute space and time exist. So let's review the evidence. Newton's law of universal gravitation is usually stated as that every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Newton's law works as if gravity is instant. Particles are attracted to each other's centers as if particles know where those centers are located at the moment. As if particles can exchange that information instantaneously. As if there's some computer that stores information about every particle in the universe. As if that computer recalculates corresponding forces and lets each particle know where it should move next. Einstein's general relativity limits speed of communication with speed of light c. It means that if our sun disappeared, we would feel that only in 8 minutes 19 seconds. That is the amount of time needed for light from the sun to reach the Earth. Therefore, general relativity does not require any instantaneous communications, but there is still something strange. Imagine that the source of gravity moves in some direction with speed v. Imagine that the distance between us and the source of gravity is x light years. The strange thing is that the formulas of general relativity seem to tell us that we will be attracted not to the location in space where the source of gravity was x years ago, when gravity was emitted, but to the location in space where the source is now, after x years of straight motion. I will put a link to an article describing that in the description. So the question is, how do we know what location to be attracted to if the source was in different location when gravity was emitted? Is the information about the current location passed to us by the source instantaneously? Or is the information required to calculate the point to be attracted to is encoded into gravity particle, whatever that is? The answer of physicists would sound like this, because it follows from equations of general relativity. Relativity requires that. Such answer does not explain much. Let me propose another explanation. According to the model I describe on this channel, light can have rest mass and therefore can move with any speed that is less than or equal to c. When light source that moves with speed v emits photons, photons move away from the source with the same relative speed c minus v in all directions. As a result, a set of photons is emitted by the source. The density of that set falls down as photons move away from the source. We can also give another name to this set of photons. A field. You can see that field as a sequence of circles. Those circles point to the current location of the source, not to the location where light was emitted. If we assume that gravity particles are emitted just like photons, we can understand how the information about the direction of attraction could appear. It's just the direction in which gravitational field density grows. No any encoding, no any instantaneous communications needed. Everything is simple and logical. You just need to accept that both photon and gravity particle, whatever that is, can have rest mass. Please note that the model used by special relativity, in which the speed of light does not depend on the speed of observer, does not provide any explanation. Why would we be attracted to the current location of the source and not to its original location? Besides, it leads to a contradiction, as it is explained in one of my previous videos. So what do you choose? Instantaneous communications? Particles with encoded information about the source? Or photons that can have rest mass? Also, I should remind you that there are other ways to confirm that light is emitted according to this specific model. And not according to the speed of light does not depend on the speed of observer model. For example, we can do that by observing astrophysical jets. I had a video on that. There are also predictions that can be tested. Some of them were mentioned earlier, some of them will be mentioned in future videos. Why people prefer to believe in special relativity? I just don't get it. As you can see, even the way general relativity works tells us that special relativity might be just wrong. What is so special in special relativity? Why its postulates are to be untouched? To say the truth, I'm tired of repeating how cool it is to be able to look deeper. Don't you see it? Don't you feel it? Where is that curiosity thing that humans should have? Was that another fairy tale? Press like, subscribe, tell your friends, and let's change the world. Thank you for your attention.